So in this video, we're going to talk about functions. This should be a little bit of a review for you, and we're primarily going to talk about linear functions, although there are many other types of functions that we'll talk about through the year. A function is basically just a special relationship where every input has one single output. And that's pretty much it. A function could be something as simple as like a drink machine, where like, I think the drinks here cost $1.25. I might be wrong about that, but for example, if I put in $2, that's my input, what's it gonna give me out as change? It's gonna give me 75 cents. What if I put in a $5 bill? Well, in that case, it's gonna give me something else out for change. And if I put in exactly $1.25, it would give me 0 out in change. So this is a function. You have inputs and outputs. The money you put in, the money you get back. Another example would be like, it doesn't even have to be numbers. For example, every move you can make on a Rubik's Cube is a function because each move creates a new output of the cube. So that's a function. You could even talk about, well, we'll get to that in a sec. You could talk about paint. Let's say we have the function like f of x equals x plus red. Let's say I mix blue, I put in blue to this function. Blue plus red would give me out purple. If I put in white to this function for x, white plus red would give me out some sort of pink looking thing. So that's a function, paint. Also, just so you know, like Instagram filters are actually very simple functions. For example, think about the filter that anytime you edit an image, where you can like slide the little slider and make it like lighter or darker. Basically what's happening there is, if you take computer science, we'll talk about this. Every pixel, like every little pixel of light on a screen is made up of red, green, and blue light, and that's it. And so when you slide that, and each of these is represented as a number from 0 to 255. 255 would be like a lot of red, 0 would be no red. So what they do is, when you slide that slider, to make it lighter or darker, it just adds more red and more green and more blue, or it takes away the red, green, and the blue. For example, it's like the original amount of red plus however much you want to add in to the slider, and this number changes the slider. So like if you add 50, it would get a little darker. If you added 150, it would get way darker. But you're just taking the input of light that was originally there and changing it by some number. That's a function. Okay. The equations we've typically seen so far, we've used x and y. When we're using function notation, instead of y, we typically write f of x. They mean literally the same thing. F of x and y are pretty much interchangeable. They both stand for the output. X is the input, f of x is the output, or x is the input, y is the output. The reason we write it like this, the way you would read this is, a function is the function's named f, so function f, with an input of x, and then this is the rule that defines the function. So this is not saying take function f and multiply it by x, although I know it's written like it's multiplication. This is saying function f, x is your input, there's the input, add 2. So as a coordinate, it would look like this. Input and output, x and y, or x and f of x, those all just mean the same thing. The input, or x, goes first, the output goes last. Okay, so we're going to do a little cryptology activity, and then you can come back to the video after you've done that. Okay, what you probably noticed from that cryptology activity is that each input in a function has to have an output, and it can only have one output. So for example, imagine that each of these dots are my inputs, And so this input has that output, this input has that output. See how every dot has exactly one output? Notice both of these dots had the same output, and that's okay, but I couldn't have a dot with more than one output. Like having multiple outputs from one input is not allowed. You can repeat outputs basically, you just can't repeat inputs. So once again, this is not allowed. You can't have an input go to multiple things. This is like in the cryptology activity when you were trying to like decode it, you weren't able to. Because if you have an input that's telling you it's two different things, then which is it? Which do we go with? But if I have an input, like say I put in 1 and I get out 5, and I put in 2 and I also get out 5, that's okay. I've heard of different ways to remember this. I've heard in middle school sometimes they say, the y values can cheat, but the x's can't. As in, the y values can have multiple partners, but the x values cannot have multiple partners. Or you could also think about it as like a school bus. So like, if you're a person, you can't get on multiple school buses. You can only get on one school bus. Although, 2 people could get on the same school bus, and that's okay. And you have to get on at least one school bus. Do you see how this dot doesn't have any output? That's not allowed either. Each input has to have an output and exactly one output. That's what makes it a function. For example, this is the function x squared. So it's a function f with an input x, and the rule is take the input and square it. So see how 3 maps to 9? The input 1 squared is 1, the input 4 squared is 16, the input negative 4 squared is also 16. That's okay, remember, and here's a table version of this map here. You're allowed to repeat outputs, just not inputs. All right, so here's an example. Is this relationship a function? Why or why not? Go ahead and pause and try that. All right, this is not a function for a couple reasons. First of all, 3 and 4 don't even get on a bus. They got left behind. They need an output of some kind. Like what if I try to do f of 3? What do I say that it is? It's nothing. The other problem here is that 5 has multiple partners, and that's not allowed. It has multiple outputs. If I try to do f of 5, what am I supposed to say? 4, 5, or 7? That's why that's not allowed. It's because I want to have one definitive output. Is this one a function? Yes, it is. Each input has exactly one output. It's okay that they went to the same output. It's okay we didn't use all the outputs because at least all the inputs didn't repeat and they have at least one, they have one arrow. This one? This one is not a function. It was close, but 2 needs to have an output. 2 needs to go get on a bus. This one is a function because every input has exactly one output. Or here's an either or kind of thing. Which of these is not a function? That would be this one. That's because 5 has 2 arrows coming out of it. 5 has 2 outputs. That's not allowed. Which of these is not a function? Instead of kind of a map, we've got tables. Notice on this one, each of these inputs has exactly one output. But here, see how I repeat the 1? 1 has an output of 2 and 1 has an output of 5. So again, if I tried to do like f of 1, would it be 2 or would it be 5? I don't know, so it's not allowed. This is not a function. It's what we call a relation. There's some sort of relationship here, but it's not a function specifically. Let's think about this on a graph. So if I were going to draw a graph that is not a function, Let's think about that table that we just had. It was 1, 2, and 1, 5 made it not a function. So if I went to the point 1, 2, that would be right here, and then 1, 5 would be right here. What happens is, if I have multiple outputs for the same input, they are going to line up vertically. Basically, they're going to kind of stack on top of each other. So this is not a function here because I have 1, 2, and I have 1, 5. So that might look something like this. Just gonna draw a random line. Yeah, that's not a function. Something else that's not a function would be a circle. A circle is not a function because let's say that this is 2, 1, and 2, oh man, let's call that 2, 2, and 2, negative 2. So this is 2, 2, and 2, negative 2. Do you see how I have an input of 2 and an output of 2? And I have an input of 2 and an output of negative 2. So for that same input, I repeated an output. They kind of lined up vertically. So, an easy way to see if a graph is not a function is something we call the vertical line test. The vertical line test basically says if I pass a vertical line through my graph, it should only hit 1 point at a time. If it ever hits more than 1 point at a time, that graph is not a function. For example, it's all good all along here because I'm just hitting 1 point at a time, but as soon as I get to right there, see how I hit all of these points? And so that is not a function because it doesn't pass the vertical line test. Same thing here on this circle. See how I'm hitting 2 points at once? I'm not allowed to have 2 outputs for the same input. And so this does not pass the vertical line test. It's not a function. Here's that if you want to write it in your notes. If any vertical line intersects the graph more than once, the graph is not a function. So use your pencil, your finger, pen like me. Do you see how right here in this graph, we actually hit it 1, 2, 3 times? And that makes it not a function. This line here is a function because I only hit 1 point at a time as I pass a vertical line through the graph. Again, this is not a function because if I pass a vertical line through that graph, I hit multiple points. Basically, for this input, I have 1, 2, 3 outputs, and that's not allowed. All right, so do these graphs represent functions? Let's try this one. This one is okay. Even though it gets pretty steep, it's still just 1 point at a time. As I pass my vertical line across that graph, it's just 1 point at a time. Same thing with this one, it's just 1 point at a time, so that one's also a function. But again, we already talked about circles. Circles are not functions because they hit 2 points at once. It might just be 1 point if it were here, but usually you hit 2 points at once. By the way, if you ever want to graph a circle, usually you just do the top half, which is a function, and the bottom half, which is a function, separately. All right, this is kind of like a multiple choice kind of question. Which of these graphs represents a function? The circle fails once again. The S fails because I hit multiple points at once. This sideways parabola here fails because I hit 2 points at once. But this one's okay. Any vertical line I were to draw through this graph, even when it gets steep, I'm still just hitting 1 point at a time. So this one is the function. All right, the last thing we're going to talk about today with functions is the domain and the range. The domain of a function is just all of its x values, all the possible inputs. And the range of a function is like, how far does it range? It's all the possible outputs. I like to think of domain as like, you know how like Simba and Mufasa are like looking over all of Pride Rock and it's the king's domain when we're talking about all the land that he owns. And so that's like the king's domain. just like domain in math is all the x values you might hit. For example, state the domain and range of the following relation. So the domain is literally all the x values. So the domain is 2, 4, 3. You can put them in order if you want, but it doesn't matter. 6 and 2. I already have a 2 in there, so I'm going to be done. And typically we write a set with these little squiggly marks. So here is my domain, just all the x values. The range is all the y values. So that would be -3, 6, -1. Again, you can put them in order if you want, but you don't have to. 6 is already in there, so that's good. And 3, I need. There we go. Is this a function? The answer would be no, because I repeated the input 2. 2 can't go to both 3 and -3, so this is not a function. It's pretty easy when they give it to you in a table or a map here. The domain of this is, domain. That's the domain, literally all the x values. The range is this, literally all the output or y values. Same thing in a table, that's the domain, and this is the range. They kind of give it to you. Go ahead and try this one, pause the video. The domain on this one is -3, -2, -1, 0, 1, and 2. That's all the x values. The range is all the output or y values, which is 5, and 5, and 5, and 5, and 5, and 5. The range is literally just 5. Is this a function? Yes, because I didn't repeat any inputs, just repeated outputs, and that's okay. And if so, go and try this. Write a possible function to represent this. It's actually a very easy function to write. This function is f of x equals 5, or y equals 5. Like literally, no matter what the input is, the output is 5. No matter what the x value is, the y value is 5. So that's this function here.